Okay, in this recording, I'm going to walk through the first lab assignment and show you what I was hoping that how things would go. Again, the reference for this is the computer lab assignment, and this is for the winter 2017 class. So I'm starting with my class project, and the first thing to do is to create a package called cards. So we will do that here. And notice that I right click on source packages, say new Java package, and call it cards. Now, at this point, the first class is the single card class, and hopefully I will show the UML class diagram for this, but this is hopefully a fairly simple class, and so the idea is we're going to call it single card. So I create a new Java class, call it single card, and the idea is that each of these cards and each instances of this will have both a suit and a value. So the suit we're going to model as a string, and the value as an integer or an int. Notice again that instance variables must be private. A little later, as I might have alluded to in class, we're going to allow protected at some point, probably not this quarter, but next quarter. However, public and the package that is without anything in front is not allowed. Now, the idea here is that these are going to have getters but no setters. And now here's the way to do that. The way to do that is you can right-click on just any place in the editor, select Refactor, Encapsulate Fields, and we can select the getters. Okay, so just as a double check, here's our suit string, here's our value int, here's the get suit, get value. We do not check the setters. I'll talk about that in just a second. So we refactor, and then as you can see, the get suit and get value are both created. Now, why not have a setter for these? Well, the idea is that once I create a card, its suit and its value are fixed. I'm not going to let those be changed. And so if you have a setter, then that will allow them to be changed, and we don't want that. Now, given that they can't be changed, how can we get these in there? The value of a setter is that's how we can set the value of an instance variable, and you want to do it with a setter in general if you're going to allow them to change the value, because, well, we're not going to allow you to directly change the instance variable. So the approach taken here, which is pretty much the only thing you can do, is to do it in the constructor. And a constructor, if you recall, looks like a method, except it doesn't list any return. However, it has the same name as the class, and it optionally has arguments. In this case, we're going to give it the suit and the value like that. Now, at this point, if we had a setter, then we could invoke the setter here, but we don't. So what we must do is set them this way. Just one thing to point out. Now notice how this suit that's an instance variable is actually colored differently than this one. And that's because even though they have the same name, they're actually two semantically different things. So this suit here and here, marked in green, is the instance variable. This one that's black, notice that it corresponds, in fact, if I click on it, see how it highlights where it comes from? This is the argument that's been passed in. Likewise, for the value, that's the one that passed in. This is the instance variable. And then notice how NetBeans highlights the one that it corresponds with. Now the final piece is to write the toString method. And this is hopefully becoming a little less mysterious. The idea is that every object can turn itself into a string. But in this particular case, we want to return what the value is of, oops, of the suit. So the value of the suit, and then here we're going to add an override notation because that was suggested. Override is a good idea because it tells you that a method has been overridden. Okay, so now having created the class and having it meet all the criteria that are listed in the UML diagram, we can now want to test it, because as simple as this class is, there's really no such thing as a completely automatic code. In other words, when you write code, it's not just going to work. You have to make sure that you verify that it works. And to do that, as the assignment suggests, we're going to create a main class called test single card. Okay, and the purpose of this test class, so here's the idea. This is just to make sure that what we've done is okay. This is a complete throwaway class. This single card class, on the other hand, that's something that we're going to reuse, and we're going to reuse it in just a moment. But for right now, before we start reusing and doing other sorts of things, we need to make sure that it is actually working, and that's what this is for right here. So really the first place to start is let's just create one and just make sure that it works. So let's create a new single card. Let's make it the spades and give it the 1. You know, so that's a okay. So so what I've done here is I've just kind of hardwired a card, and all I'm doing is I'm just verifying that this is going to print the right thing. And so when I just print an object, what it does is it calls the toString. It calls the toString of that object. So what I'm expecting is this should print the 1 of spades. And when I run it, indeed it prints the 1 of spades. So, you know, what could go wrong? I could maybe forget to put the value in. Supposing I had forgotten, and I'll just comment it out. Supposing I forgotten to put the suit in. Now when I run it, it's going to be the first of null, 1 of null. I'm going to say, well, wait a minute. What happened? I told it spades. So how do you track that down? Well, one way, and actually NetBeans has this little nice feature where I can right-click and navigate to the source. Okay, and the source here, well, actually it should have taken me to this. Let's see. There we go, to the constructor. And then I notice, whoa, something happened. I forgot to set the suit. So I can fix that, run it again, and now this is working. Okay, so so now at this point, what I need to move on, and after doing this, let me comment this out here. And the objective is to create all 52 cards. Again, this is all for a test. The fact that I was able to create one card doesn't necessarily mean that it's going to be able to create every card the right way. So the way that I'm going to do that is to create an array of single card. Let me call it a deck. And my deck, I want to have 52 of these here. Now, actually, what I could do instead is say something like int number of values is 13. Say that's, and then int number of suits is 4. And then I can do this. What I like about this is that this makes my intent a little more explicit. This says if I'm reading this says, okay, he's going to have values, he's going to have suits, and then by multiplying them, that means this is going to contain all the different combinations of suits and values. Okay, so now what I'm going to do is my outer loop is going to be the suits. So let int suit is 0, suit less than number of suits, and then plus suit. Okay, so that's the outer for loop. So I'm going to loop over the suits first, and then inside the values. For int value is 0, value less than the number of values, and then plus the value. Okay, so now I have a little bit of a conundrum, and that is that my suit is going as integers here, but I need a string. Okay, I need a string. So how can I do that? Well, the suggestion, well, I don't know if it was a suggestion, but here's how I can create what I want. See, notice my suits are going 0, 1, 2, 3 in this silly off by 1 business. And so how can I map an integer into something else, like in this case a string? And that's where arrays come in. So instead of this, let's call it suit names. Okay, create a string, my suit names. Okay, so now I can say this is the number of suits, and then my suit names 0 is going to be clubs. Suit name 1 is diamonds. 2 is hearts. And the final one is spades. And now I can use that in my loop here. So now, in fact, my suit, rather than going to number of suits, it's actually, even though it's the same thing, what would be better is to go to the length. Whenever I'm iterating over an entire array, it's always best to go with that, with the length of the array. Okay, so now my deck. Well, I need to come up with an index, if you remember, and this is very similar to what I did in class. Okay, so let's see how we can figure out what the index is. So the index is going to be my my suit times the number of values plus the value. Okay, so this is very similar, but again, you can just sort of walk through this and see that when suit is 0, this whole first expression is going to be 0, but value is going to go from 0 through 12. Then when suit is 1, this is going to start at 13, and then value is going to go from 0 to 12 again. So that next one will go from 13 through 23, etc. Okay, so that's how I determine the index. Deck. The deck at that index is equal to new single card. All right, now I need to give it a suit. It's making a suggestion which is not the greatest. What I need to go is suit names of the suit. Okay, so suit names is the array, and so when suit is 0, it'll pick off clubs. When suit is 1, it'll pick off diamonds, etc. So when I'm finished with this, then I have my entire deck. And so to test it out, oops, what happened? Let's do it in here. So okay, again, deck dot length. So now I'm just printing the whole thing out. I just print line the deck at I. And there are some simpler ways to do this, but now we're finally ready to run this, and let's see what happens. Okay, so we see that. Okay, the 0 of clubs, the 1 of clubs. Okay, now that's not quite what we want. 0, 1, 2, 3. So because of the silly off by 1 business, one way around that is to simply add 1 to the value when I create the card. So now when I run it, okay, so I have 1 of clubs, 2, 3, 4, etc., up to 13 of spades, and that takes me to what that does is that validates the fact that I've created my cards. I've found a way to put them into this array, which I'm going to use in creating the next class. But this was just to one, partly test that, and two, to be kind of an exemplar for how I'm going to conduct the next one. Now, before I do anything else, what I want to do is just add some comments. So here in the single card, I'm going to say instances of this class represent a single playing card in an ordinary deck. And then here, and just the given value of this card, and what am I doing here? Instantiate a single card with a given suit and value. Again, comments are always valuable. Now, since I've edited this, even though I've only done comments, what I want to do is, before I do anything else, just double check that I haven't broken anything. And now once I've done this, I do want to commit. So I want to, okay, one way I show my changes. So here's what I see. I have my locally new package cards, and then here are the two classes that I've created. So I do want to commit this, and what have I done? I've created single card and tested.